Hello and welcome to a Saturn Online presentation entitled, Why Measure Shell Air Leakage? You've made this commitment to learn about blower door testing and duct blower testing. I mean, why do we even do it? I mean, it's a lot of trouble, isn't it? Well, why do we measure anything? We measure because we want to reduce uncertainty about important decisions. How much money do we spend sealing air leaks? I mean, is it important to seal air leaks in a particular house, or isn't it important? Is a house already very airtight, or is it very loose? We don't know. And let's go back and review just some real basics. We have something that I'm going to call shell energy waste, and we have a wintertime version of that and a summertime version of it. And the wintertime version just has two parts, air exchange and heat transmission. And the summer part has air exchange, solar gain, and heat transmission. The solar gain in the wintertime isn't that much of a factor for most homes, so we neglect it. Now, air exchange means both unintentional air leakage and ventilation. And sometimes those two are mixed up, or they're one and the same, or they're, air leakage is providing ventilation. So I'm calling it air exchange. So air exchange, in the wintertime could be anywhere from 10 to 50%. How do we know? It could be an unimportant problem, or it could be a very important problem. We don't know. Well, if we look at heat transmission, as long as we can look at the insulation and we know, the R value per inch of the insulation, and we know how much insulation we have on a particular building assembly, this is a known factor to us, this heat transmission. I mean, we don't have to go out and measure anything to get a good idea what's going to be lost, how much waste we're going to have in the winter through heat transmission. Now in the summertime, air exchange is going to be a little less because solar gain is so dominant. And so we got 5 to 35%. But again, is it 5%? Is it 35%? We don't know. With solar gain, I mean, we don't have to take a solar meter and go out to the house and measure each side of the house to see how much solar energy is falling on the roof and falling on each of the walls. We pretty much know that. We can look that up in tables. Heat transmission, again, if you know the R value per inch, how many inches of material, that's known. So both of these are known. We're trying to get more information about this unknown. We're trying to reduce uncertainty. Well, we want to know how much time and effort do we spend to seal the air leaks. And we want to also say, what is our plan for ventilation? I mean, most homes are ventilated by natural ventilation. In other words, there's not a fan operating, there's just air flowing in and out through the air leaks, and that serves as ventilation. But there's also a fan-assisted ventilation when the house starts to get tighter. Now sometimes we're running bathroom fans on a low speed, or we've installed a fan in a central location to do some ventilation for us, to assist with the natural ventilation. Or we may have a very, very airtight home, and we have a fully ducted and balanced distribution system. And so it helps us to know, do we have a really leaky house? And if we do, and if we're not going to do any air sealing, then natural ventilation is going to be fine. If we have a home that has undergone a lot of air sealing, we're going to need a fan. And in this fully ducted, balanced system for the energy efficient homes, we need 2 fans. So that's why we measure shell air leakage.